Hello, welcome. Bonjour, I think it's the right term. I can't speak French. The only thing I can say in French is je suis très français. Thank you very much. That was the presentation, yes. So my name is Christian Thalinger. I work for Twitter, and I live in Hawaii, which is a very nice place, but I'm super stoked that it's so warm here. Yesterday was super warm, today is super warm. I like it a lot, so I don't miss Hawaii too much when I'm here. So first of all, Twitter has a VM team, and so we have our own hashtag Twitter VM team. So who in here, the lights are really bright, but who has a Twitter account? Yeah, that's a pretty good turnout. So I want you to tweet about this talk, and if you do, I would appreciate if you add that hashtag, and then my people at home will see that I was actually here and I was doing a talk and not just drinking and sleeping in the hotel room. A while ago, I gave this presentation, and then someone tweeted later, "Oh, Christian told me to tweet this, otherwise he will block my account." I'm not saying I'll do that, but Anyway, so this talk, what's the goal about this talk? First of all, who knows what Graal is? Okay, a few people. Who knows what a JIT compiler is? Okay, a few people. So there was a Graal VM announcement yesterday. I'm not talking about this, so it's a little confusing because Graal VM is more than what I'm talking about. Graal VM is like this umbrella project that contains Substrate VM and Truffle and Graal the compiler and other things. I'm only talking about Graal the JIT compiler. So a JIT compiler is a compiler in the JVM that takes Java bytecode and translates it into native code so that your application runs fast. So we're talking about this. Good. So what's the goal of this talk? To save money. That's exactly what we did at Twitter. So I'll walk you through what we've done at Twitter, what I've done at Twitter when I joined them, and then it was basically about a year. It took about a year, what I'm telling you today, to get to the point where we are today, basically. And first of all, let me tell you a little bit about me. So my name is Chris. I work for Twitter right now. I'm an Oracle Developer Champion as well, which is not important for this talk, but in my other talk it is. So I'm working on JVMs for over 13 years now, or maybe even 14 now. I don't remember. So for a long time, and all of these 13 years, I was working on compilers. So I know nothing about GCs. Well, that's maybe an overstatement, but I know a little bit about GCs. Don't ask me GC questions. You can ask me a ton of compiler questions. I can answer all of them. So back in the day, 13 years is a long time ago, back in the day, so let's out a few old people. Who remembers GNU GlassPath? It's very good. Old people. Like me. So back in the day, we were all working on GNU GlassPath, right? We were the Wild West against Sun Microsystems, the big bad guys, and we were fighting it. And then suddenly they open sourced Java, and then we thought, okay, that's cool. And they showed up at FOSDEM, and we were all drinking beer, and we were super happy about it. And then a few years later, I started working for Sun Microsystems, and I was part of the Hotspot compiler team, working mostly on C2. So who knows what C2 is? Okay, so C2, I told you JIT compilers. So Hotspot, the JVM Hotspot, has two JIT compilers. One is called C1 or client compiler, and the other one is called C2 or server compiler. You might remember this dash client, dash server thing. That's exactly that. There are two JIT compilers in the JVM right now. And so I was part of that team, and I was mostly working on C2. And then I did a small thing called JSR 292, which was adding invoke dynamic to the VM and to the it's not really part of the language, but to the VM. So John Rose and I were working on this for many, many years, and it was a big project. So technically, if it doesn't work, you could blame me. But a few people after me touched the code, so let's blame them. Then I was working on something for JDK9 called CHEP 243, the Java level JVM compiler interface. And that interface is, we took it out of the Graal project, which is the interface between the JVM hotspot and a compiler that's written in Java. So Graal is written in Java. I haven't mentioned this yet. So we've added that in JDK9. And then the other thing we did in JDK9 was CHEP 295, which is ahead of time compilation. So you can take Java class files, compile it down to a shared library, and then load that in and run from that. So that, I'm not talking about this, but that's something we worked on. And one of the reasons we worked on this was because we wanted to be able to AOT compile Graal itself. That's something I will explain tomorrow at the same time in this other room over there, where I'll show you how to use Graal, and I will talk a lot about what bootstrapping is, because that's something you have to know. And now I work for the Twitter VM team, which is great. Love it. So you guys probably know what Twitter is, right? It's a huge distributed system. We have many, many services. The most important ones are tweet service, user service, social graph service, and the timeline service. That's pretty much everything you do on Twitter today, right? You open up your app, you get a timeline, you send tweets, you read tweets, and then the social graph is who you follow and all this. So these are our biggest services that we have. And then we have hundreds of other services as well, like DM service and URL service and image service, you name it, right? Tons. And these services have run on many JVMs. So we have thousands of instances of our big services. And we are running thousands of these JVMs on thousands of machines in multiple data centers. So it's a pretty big, business that we are running here, and the expense, the cost for all this is pretty high. So if we can somehow make that run better, more efficient, produce better code, for example, then we can save a ton of money. So this is what this talk is about. Twitter also does a lot of open source. We use a lot of open source. We also release a lot of our stuff as open source. There is a GitHub, I don't know what it's called, I always forget what it's called. It's not a business. There's a GitHub something, Twitter something, where you can look at all the projects we have, Finatra, Finagle, and Pants, and I don't know, all the stuff that we release. It's just, we release basically all the frameworks we are building at the bottom, just not the top layer. That's the IP logic that actually Twitter is. So for us, Graal is a good fit because it's open source. It lives on GitHub, and we're contributing to the project too. I'll show you that a little bit later, what we did there. And the reason why Twitter has its own VM team is because we have our own JDK. So we build our own JDK. It has a few improvements. We do this mostly for support, right? If someone has an issue, and then we don't want to pay Oracle a shit ton of money, and the turnaround would be too long anyway. So if we can fix it ourselves, much better, right? So that's what we do. And so I told you Chap 243, JVM CI, is part of JDK 9, but we need it in 8 because we run on 8 in production, so we backported that. Well, I did. So I backported that. Then we have included Graal in our JDK. And then there's something called Contrail, which is now moot because Oracle decided to open source all their stuff, and JFR will be open sourced as well. So that's not really, I could take that out soon. And then we have a few CMS improvements, which I think is not true anymore, because as far as I know, we've upstreamed all of them. And CMS is deprecated anyway, so who cares? So why Graal? C2, as I explained earlier, is this one JIT compiler that is used. C1 is basically a compiler that produces code fast. It has high throughput. You want to get away from the interpreter as quickly as possible and run on native code. That's C1. And C2 is a highly optimizing compiler that produces peak performance code. So, but C2 is very old and very complex. It's super hard to learn. The learning curve is way too steep. I've seen this many times, especially when I was working at Oracle, and we lost a few people. And then we hired new people, young people that might have worked on the JIT compiler before or not. And to be honest, me personally, when I started working on C2, it took me almost 3 to 4 years to fully understand how it works. And that's something, when you bring in new people, they get frustrated. Because usually you look, these days everyone looks at open source projects and works on them and blah, 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 GitHub, whatever, and tries to contribute. It takes them maybe a few weeks or maybe a few months to understand how it works, but not years. So these people left. I don't know exactly why. Maybe they thought they were stupid, or I don't know what. So we have to get away from this because we need to hire new people to do this, because at some point I would like to retire and then someone else needs to, Then in the last few years, there were no major optimizations in C2, like groundbreaking new stuff. There was only the things that were done were Intel was releasing a new vector instruction set, AVX 512, and you name it, and then they contributed handwritten intrinsics. An intrinsic is handwritten. You can replace one very good example I always use is string.indexOf. Right? There's a Java implementation in the core library, but there is a handwritten assembler code that that hotspot and C2 replaces then, because it's much faster to do it in AVX than just the compiler could produce code for it. So a lot of these intrinsics were done, but that's not really something fundamental to the compiler that makes all the code faster, right? So that's what we want. And in my personal opinion, C2 reached its end of life a long time ago, because we've been doing this, what I just said, with this intrinsic stuff like for a couple of years now. There's nothing happening. So we would like a new foundation where we can just build new stuff on top. And so Graal is very easy to understand. It has a very modular design. You see that screenshot, that's kind of old screenshot, but it has like 80 they don't really call it modules, but it's something like a module, not a JDK 9 module, but they grouped it up in packages, and then their build system makes sure that you don't have circular dependencies and things like that. So that's very neat. And then, very important, Graal has better inlining and escape analysis. So I think most people know what inlining is, I'm assuming. Escape analysis is if an object allocation is not necessary and does not escape the scope of your method, you can eliminate it. Okay, that's very good, because then you don't have garbage on the heap, your code gets tighter, and so on and so on. So these two optimizations are very important, and these two we'll be talking about later. So we found a few bugs when we started running Graal at Twitter. So, and I'll just walk you quickly through this. It doesn't really matter if you understand what an OSR is or anything like this. It's an on-stack replacement, but you can read it up if you want to. I should really give a talk explaining what all these things are. But so we found bugs upstream, and then we found this one bug, and it looked like when you turn on print compilation, the log output looked something like compile skipped, OSR with logs not supported, blah, blah, blah. You get an exception that looks like this, because Graal is written in Java, so you get nice exceptions when something happens in the compiler. So it looks like this, right? You see phase run, and then you run that on-stack replacement phase, and it kind of bails out. So Tom is an engineer at Oracle Labs, so we discussed this for a little bit, and we decided at that point in time that it's not a big issue, because we are running tiered mode anyway, tiered compilation. So if the method cannot be compiled in tier 4 with Graal, it will be compiled with C1. So we're still running on native code. It might not be as fast, but this was not a very important method. So we said, okay, let's leave this for now, and it's fine. But then eventually, a little bit later, I forgot his real name, Leopold something, he fixed it. So it's fixed now, it's in there, and it works fine. So it was actually a rather big change. If you see like 1,000 additions, so 1,000 new lines of code is quite big. So that was one bug we found. And then this was fixed, but then I tried to verify it if it's really fixed, and I found these other issues. And so Tom is asking for, there's this no on-stack replacement nodes, that one exception basically. And so Tom says there's a little piece of logic in C2's parser which allows access to static fields within the static class initializer, and so on and so on. So there's a tiny little bit of code that looks like this, and the method is called static field OK in CL init. So it's when you compile a static class initializer, which is very unusual because a static class initializer is only run once. So if you compile it, it's either very long or it has loops in it, so it gets hot. And if that happens, you actually really want it to compile because you're waiting for the class to be initialized until you can continue. So it's a problem with a final field that you want to access, but it's not final yet because you're just running the static class initializer, so it's like this chicken egg issue. But you can work around it because you can trust yourself. You're the compiler, you know what you're doing. And so this code basically, C2 has that code, but Graal didn't. So we just added the same logic in Graal. It was just missing. It was rather small, right? It was like 30 lines of code. Done. Good. So we fixed that. Then we had this one, which was very annoying. Don't really care about the error message. Basically, the VM crashed, core dumped, basically. And the issue was it only happened with long-running processes. Like, it had to run our service for multiple days, and then it crashed. So, and I thought, oh my God, how should I find this, right? So it turns out I was playing around with some command line options that we were using, and it turns out we're using an agent that's called Heapster. And you can download it on GitHub if you want to. And Heapster, so here's what it says on the GitHub page, an agent library to do heap profiling. So heap profiling always means instrumentation, and that means you're instrumenting all the allocation bytecodes, like new and new array and so on. And so you get a profile of the data of the types you're allocating. And the problem is that Graal is written in Java, right? And so if you have an agent installed, it also instruments Graal itself. And that was the issue. So there's something called snippets. I'm not going into detail here what this is. It's something like an intrinsic, what I explained earlier. And so there's one snippet that had a double dot value off in it, which does a new, and that was instrumented. And snippets are treated very specific by Graal, the compiler. It's compiled differently than regular Java code, and that's where we crashed. So, and then, they were discussing it, and then Doug said, okay, I think it's time to bite the bullet. So they did that, implemented this. I'm not sure how long it took, but it was 2,700 lines of new code. But it was important because people in the wild are using agents, like we did. If Oracle Labs is running spec-GBB for the millionth time, yeah, of course, they won't find that bug, but we did, because we're using agents. I'm sure you guys do too, or at least some of you. So that's fixed, works perfect. Then we had this problem that we had this connection exceptions showing up in our log files when we were running a service. And so I was looking at this, and I really didn't know where it's coming from. The problem with microservices is if you have an issue, you don't know if it's yourself or if it's the guy you're talking to, big issue. And we have hundreds of services, so I didn't know exactly what to do. And then, completely unrelated, I thought, because we were upgrading to Netty 4 or something, I can't remember. And it's a while ago, right? So we were upgrading to Netty 4, and I thought, oh, maybe I should run the Netty test suite, which I did. And then, boom, Netty buffer failure. Okay, well, that sounds interesting, so let's look into that. What happened? So this is a really, really odd bug. There is a thing called, on the number classes, like integer and short and all these, reverse bytes, just swaps bytes, right? And so in this case, it was a short reverse bytes, and there's an intrinsic in Graal that does that to boil it down to just, because the x86 has a machine instruction for this, to just boil it down to one machine instruction. And this was wrong. It didn't work properly. But this is being used all the time, right? So I still to this day, I don't know why just in this case it actually didn't work, but all the other cases it did. So Tom knew what the issue was, so he fixed that. Was 5 changed files, 68 additions, but that included a test case, small fix. It was basically a 2-line fix. So that was that. And these were all the bugs we found. And since then, nothing. We're just running fine. We're running the big services I mentioned earlier, tweet service, social graph, and the tweet service. Oh, I already said that one. These are running 100% in production today for 9 months now. And we didn't have a single issue. And I guess did anyone lose tweets or anything? No, it's all good, right? Perfect. So that was really it. Then I thought, okay, we should give back something to the community as well. We are using this, saving a ton of money, but we're not giving back. So I was working on something called, JDK 9 has compact strings. We're not running on 9 yet, but I knew at one point we will, or at least 11. And so the way compact strings is implemented in a compiler is a little unfortunate because I wanted it to be different, but they decided to do it with handwritten code. Super annoying, so we had to port that over. So we ported at least well, I did one, the big one. I ported over the string.compare2. It's a lot of handwritten assembly, and you just had to port it over to Java because it cannot use the C++ version, and so on and so on. So I did this at some point. When you look at the third line, you see with very long strings, it took 2,600 whatever nanoseconds, and then after it was 126. So huge improvement. The important one is that the bottom table is exactly the same, looks exactly the same as with C2. So we're just on par. That's what we wanted. So we did this. Was someone else actually then finished this up because I didn't have time. So Dmitry Samosov did that, and it was like a new 1,000 lines of code. So it was a lot of handwritten assembly code that we ported over. So that's all I did. And then I started going to conferences and don't have time anymore for this. But that's why Dmitry finished it up. Really, that's the truth. So let's come to the important part, to the numbers. And there are a bunch of graphs, and so I'll walk you through them. I used a tweet service as an example, and it's a Finagle thrift service. So Finagle is one of our open source thingies that it's an extensible RPC system for the JVM used to construct high concurrency servers, whatever it is, I don't know. It's some web server thingy, I guess. Most important thing, it's 92% Scala code. So almost all of our services at Twitter are written in Scala. And the remaining, where is it, like 6% Java, that's probably Netty or something, I don't know. So the test setup I used for this was, I used a dedicated cluster, so I had my own machines. That's important because you're running in a cloud world, container world, you're running multiple things on the same machine, and then you have a lot of cross-talking and your benchmark numbers are not really reliable. So I had my own dedicated machines. I used one machine per instance or configuration. Configuration here means C2 or Graal and so on. JDK8 and JDK9, I tested both. Very important, all instances receive the exact same requests. Not only the same number of requests, but the exact same requests, and that's important because a tweet can be 1 byte long or 280 these days. Back in the day, it was 140. That was cool, but now it's 280. I was using. I just put it in there if people, no one really cares. JVM CI 0.30 and the Graal VM version 0.22. I think these numbers are, what do we have now? It's like almost 1.5 years old, almost, I guess, something like this, a year old. So we are running by default in a tiered compilation setup, as I mentioned earlier. So you start up. You run interpreted for a while, not very long actually, then you compile with C1, you compile code that does profiling, and then you use the profiling information to compile with Graal. That's how we run. And as I mentioned earlier, the bootstrapping issue is, I'll explain it tomorrow, but for our service, it's not really an issue, and tomorrow you will see why it's not really an issue. And if it would be an issue for you, if you want to try this the same way and it is an issue for you, and you can run on JDK9 or later, you can AOT compile Graal, and then all this goes away. But we can't because we run on 8, but it's not a problem. Okay, so this is 24 hours. That's 1 day of tweets being read. This is read-only data, by the way, because in an experimental setup, you can't write data to our storage. So this is read-only. At the bottom, you see the time, but you will notice there is no y-axis. And the reason for this is because it's proprietary data, it's confidential data, I can tell you. Okay? But I'll show you the improvements that we're seeing later. I made it so that you'll see it. You see blue is C2, orange is Graal. These are Java 8, JDK 8. And then it did the same tests with JDK 9 just to see if there's any differences. But you see, they all received the same request. That's important here. Okay. So the tweet service is using parallel GC. That's why we're looking at scavenge cycles here, and it's a moving average of 60 minutes, so it's like it's flattened it out a little bit. But we want, what I was telling earlier, what we would like to see is with the better inlining implementation that Graal has and the better escape analysis implementation, we would like to see less GC cycles. That would be cool, right? Because then we know, okay, we're not allocating as much garbage, and we're not wasting the time to do GC cycles. Okay, let's take a look. Yes, it's better. Perfect, that's great. So we don't see yet how much, because y-axis issue. So there's JDK9, C2, it's roughly the same, and then Graal, JDK9 is exactly the same. And it's about 2.5% less. It's not a lot, but if you can save 2.5% of your GC cycles, that's great. And you also, you're saving, you're not allocating the object, which is very important, because allocating an object in your compiled code takes quite a bit of space. If you can eliminate that, your code gets tighter and runs better, faster, okay? So that's what we want. So 2.5, it's not too much, but it's good. Something I should mention is, because when you talk to service owners, everything basically I did at Twitter, I didn't do except that contribution I did. I did not really do software development. It was all not software engineering, I was doing social engineering. Because I had to talk to our service owners and tell them, hey, there's an experimental chick compiler no one's using in production, you want to use it. It's a hard issue. So, and they are monitoring when they try something new, they are monitoring all their metrics very closely. And one of the metrics, some of them pointed out, is that the old gen used slightly more memory. And the reason for this, and it's about 40 megabytes. And the reason for this is, Graal is a Java application. It has some state, right? So it's 40 megabytes of state. But this does not change over time. And it's not a ratio or a percentage of your old gen size. It's just 40 megs, it doesn't matter. If you have a 200 megabyte old gen, it's 40 megs. If it's 2 gigabyte, it's 40 megs. And the same is true, I don't have a good graph for this, but the same is true for metaspace, because Graal also has Java classes that needs to be loaded and so on and so on. So it's using a little bit more memory there, but it's not a big issue. They just noticed, they said, oh my God, memory leaks it. Nah, not really, we know. Okay, this is the most important one. So user CPU time. That's something we really want to reduce, because if we can reduce user CPU time, we can serve the same amount of requests. So we are not, in these graphs and in this experiment, we're not looking to serve more requests. We want to serve the same amount of requests doing less work, right? That's what we want. If we can do that, we could, serve more requests in the machines and make our machine park smaller for this one service. So that's what we want. Okay, user CPU time. So we want that to be better, and it is. And that's very exciting. So this is C2 with JDK9. It looks like it's better than 8, which I don't think is really true. It's just this one experiment that I did, and sometimes what can happen is inlining, it's a race condition of compilations. And sometimes the compiler can decide, or the VM can decide, okay, I compile this now, and then you have a problem later inlining it. So I'm not going into details, but I think something like this happened here. That's why JDK9 looks a little better, but I think it's the same, because there was no improvement in C2 whatsoever in 9. Okay, but Graal is exactly the same, okay? So let's look at this on a ratio, and now I can show you a y-axis, and you can already see roughly how much it is. And it's 11%. And this is huge. I mean, I don't know how many compiler engineers are in this room, but if you ever worked on a compiler and you tried to make it better, if you get 1% improvement, you're already excited. If it's 2, it's like a lottery win, really. But if you get 11, it's amazing. So this is what we did with the tweet service. And I have to say, this is an isolated experiment on dedicated machines. When we moved this over to production, it turned out to be, and then writing tweets comes in as well, and cross-talking and things like this. It kind of boiled down to 8% improvement in production. And this is big as well. So I mentioned this earlier, it runs 100% on Graal in production for a long time now. As well, oh yeah, you should tweet that to the Twitter VM team, that they're really cool. and as well as the other services that I mentioned, plus a bunch smaller ones that I can't even remember which ones we converted. We haven't converted all of them yet, because, as I said, it's we soon will just convert all of them without telling the people. But right now, we have to go to them and talk to them, and that's always a big issue. If you have the big services converted and they work fine, it's easier because you go there and say, hey, look, the tweet service is doing it as well. So I've done this, but it still works. So we're just waiting for the right time to switch everyone over, and then we'll see if Twitter still works. Right, user service, social graph service, they all run 100% on Graal in production. So is the 11% that we are seeing, is it escape analysis? You know, you've seen it was like 2.5% less GC cycles, but is like everything we're seeing just because we're allocating less temporary objects, or is it something else? So I did another experiment, and I turned off escape analysis for both compilers, for C2 and Graal. It's a different run. You see the curve is different. It's a different day, but it's, again, 24 hours. I'm comparing C2 and Graal here. And scavenge cycles, what we want to see here now is, yes, they should be exactly the same because we turned off escape analysis, and that's the case. So we get the same number of GC cycles, so escape analysis is off, and so we can actually see if something else in Graal makes code run better. So we're looking at user CPU time again, no escape analysis, and it is better. And it is 5%. So just other optimizations that Graal has, I didn't really look into what exactly it is, but I'm pretty sure it's the better inlining implementation that alone already gives you 5% of improvement here. And so the remaining 5-6% is then escape analysis, which is great. So how much money is this? Well, I can't tell you, obviously. I couldn't show you a y-axis. Why do you think I can tell you how much money we're saving? So I made up this fictitious your company, and we do a little back of the envelope calculation. Some people of you might be running your own whatever cloud, something business, or maybe you even have your own machine, so you know how much money you spend on your data centers. But for others, I was looking at cloud hosting providers, how much they cost, so that's very different, you know, whatever. So I calculated it out, and it looks like this: between $72 a year per CPU core and $210. So the number one lesson you have to take away from this talk is choose your cloud provider wisely, because you can lose a lot of money just by doing that. Okay, so I thought, okay, because it doesn't really matter, I just average it out. It's $127 per year per CPU core. So now it comes down to, okay, how many cores are we talking? I told you earlier we were running thousands of JVMs on thousands of machines, thousands of instances, blah, blah, blah. So I was Googling around, because I can't tell you that either, right? So I was Googling around, and there's this Bloomberg article from 2014, and it's talking about Amazon and Google and Microsoft, how many servers they have. And it says down here, Amazon over 1.5 million servers globally, and then this other research analyst says at Gartner, or maybe it's even 2 million servers, which is ridiculous, right? And then it's servers, that means they probably all have 24 cores. It's massive. We're not that big, but you know. And then Microsoft down here says something, had over 1 million servers within its data center infrastructure, blah, blah, blah. Google had even more, obviously. Yeah, I mean, Google is huge, right? So many is the answer. Your company is probably smaller than Google, I'm assuming. So let's pick a random number. Let's say, okay, you have 10,000 servers. It's quite a big number, but you know, I thought whatever. And so each CPU usually has 24 cores. So we say $127 per year per CPU core times 24 times 10,000 servers is $3 million you have to pay just to run your business. If you could save 11% of this, that's a nice chunk of money. That's more than I get paid. I mean, I don't know about you. You know, well, that's salaries here in Paris. Maybe I'll move. So that's a lot of money, and so we are saving, you know, 11% of this experiment. But can we get more? And so what I was doing, I sat down an afternoon and I thought, okay, there are a few inlining parameters you can tune with Graal, with C2 as well, but I did it with Graal. So I sat down an afternoon, I was just looking at log files, what's being compiled, what's being inlined, what's not being inlined, and then I tweaked them a little bit, and this is what the outcome is. So I did this experiment the same day as the first experiment, so this is the same graph as we've already seen, and then there's a new color in here, that's my experiment with the new inlining flags. Okay, so again, you've seen this graph before. Scavenge cycles would be nice if we saw a little less here too, and we do. And it's another 1.3% or 1.5, depending on the load. So that's big, right? And then let's look at user CPU time. We've seen that graph before, and yes, we get more there too. And on the ratio graph, it looks like this, and it's another 2%, which is a lot of money, going back to the $3 million thingy. And I can tell you Twitter has more than 10,000 servers. I can tell you that for sure. That's a lot of money, right? Just by fiddling around one afternoon. So is there any official support for this? I mean, I'm assuming the company you work for, you don't have your own JVM team. So it's probably official support is important to you. But luckily there is. So JDK9 contains Graal because AOT that I was talking about earlier that I was working on is using Graal as the compiler. So it's using Graal, basically AOT is a Java application that's using Graal to produce native code and then stick it into a shared library. That's how it works. And it can also be used as a JIT compiler in JDK9 because I made it that way and no one knew. So it's an experimental VM option, JVM CI, you have to turn that on. This is what we're doing tomorrow if you're coming. We do all this, and then you enable JVM CI, and then you tell use JVM CI compiler, and if you add these command line options, then you're running on Graal, if you're running JDK 9 or later. And then, yes, right, I already mentioned this. So this is the talk tomorrow, how to use the new JVM JIT compiler in real life, because I've seen that people make mistakes when they use Graal. And I explain to you tomorrow what the mistakes are and to not make them again. Oh, and if you can't come, it's like on YouTube as well. You can watch it on YouTube too, but it would be cool if you would show up. So now, JDK 10 is out because schedule was 320 and they actually did that. So JDK 10 is released. Probably not many of you are running JDK 10 in production yet, but you know. But it has chapter 317 experimental Java-based JIT compiler in it. So that's Oracle's way of saying, okay, we are kind of supporting it, but it's still experimental. And the reason why it's experimental is it's because it's not mature enough, right? Not a lot of people are using it. And so one of the reasons why I'm giving this talk and all my other talks about Graal, because I want you to try it, because I want the compiler to become a mature compiler and to work for everyone. You know, you can, as you've seen, you can save money, but it's also, we want this compiler for all the other reasons I said. We want new people to work on it. We want more optimizations coming in the future, but we need to make the compiler production ready, which for us, Twitter, it is, but it doesn't mean it works for you because we've had bugs when you started using, so maybe you will have a bug, and that would be nice. So if you start running it and it crashes for you, that's great, actually, because you file a bug, and then we, Twitter, don't run into that issue and bring the whole system down. So that's why I'm asking you, try it. If you can come tomorrow, and then I'll tell you a million more times, try it. So, but in 10, you have it. And then on top of it, maybe I should mention this because I'm a nice person. Graal VM was released too. You could technically use that too. Then there's something called Project METROPOLIS that was announced September last year, and by John Rose. And John and I, we were talking about this. Do I have another one? No. And John and I were talking about this for many years now. And what we want is we want to use more Java in the JVM. So it says down here, blah, blah, blah. Our starting point is earlier proposals for using Graal compiler and AOT static compilation technology to replace the hotspot server compiler, C2, and possibly other components of Hotspot. So one thing that Metropolis, I'm not sure if someone's working on it right now. I can't work on it because for Twitter, there's not really a business case for it. I'm not sure if at Oracle someone's working on this right now, but there's definitely components you can replace in Hotspot that are written in Java. Number one, the compiler, because that's what we are doing here right now. Then one other thing we've been talking about for the longest time is the bytecode verifier, which would be easier to implement in Java. Potentially, and I think we really should do this because it would make so many things so much easier, the interpreter. That would be nice. To write the interpreter in Java and then AOT compile it. That would be cool. All right. So I think that's my last slide, actually. It's just a recap, right? So I told you that most of our services are written in Scala, and I have to mention this because it's important. Because this is the main reason why we are seeing this big improvement. Scala is just, it's not really accurate, what I'm saying, but Scala code is the other way around. Java code, I'd like to say it's a little more static. It's not really true what I'm saying, but it's like when you look at Java bytecode, it's much more straightforward. But when you look at Scala bytecode, it's much more convoluted. And Scala has a much more polymorphic nature to it. And so the whole inlining thing that we were seeing earlier, right? We turned off escape analysis and we saw a 5% improvement just by inlining is because Graal can optimize Scala code so much better. With Java code, it's very different. So I like to say it's a 50-50 chance if it's better or not. Most of the time, when it's not, it's the same, right? It's the same performance. Because C2 is a very good compiler. So it produces very good code, and so Graal can't really, optimize more out of Java code sometimes. I know of benchmarks that run, as I said, like exactly the same as with C2. I know Java benchmarks that are I think even one is 10% better, faster. So it's possible, right? If you run a lot of Java code, you should definitely try it too. I can't promise anything, but there might be an improvement. For Scala code, with very high confidence, I can say, yes, you will see an improvement. And then before someone asks, because I get this question pretty frequently lately, I have not tried Kotlin. But I'm talking to the right people right now. Josh Long, he said, oh yeah, I have something in my Spring, whatever he has, but we haven't had time to do it. So I'll also have to talk to the Kotlin people if they have a bigger application or some benchmarks that we could try, because there might be a possibility there too. Okay, I think that was it. Twitter VM team, thank you very much. And I have about 1.5 minutes for questions. Any questions? Yes, one question. There's a microphone.
Good afternoon. What is the difference with the Graal VM itself, which is announced yesterday?
So Graal VM, as I mentioned earlier, what Oracle Labs is calling Graal VM is a JDK where Graal is the default compiler, and then it has additional things like Substrate VM and Truffle, where with all the other language implementations like JavaScript and Ruby and so on, and you can compile things down to native code, like to a static executable. That's what Substrate VM is. But it has, I don't want to bash on it, but it's something that we Twitter don't need. What we want is we just want Graal, the JIT compiler, and then get the improvement out of it. Because everything, if we would use Substrate VM, that would not work for us. We're not using any other languages for our big services in production other than Scala, so we don't need all this. All we want is Graal the compiler, and Graal the compiler, as you've seen with JEP 3.17, is now part of OpenJDK. That's what we as Twitter and I care about. Graal VM is a whole different thing. If you're running a lot of JavaScript and you want to interoperate with other languages, that's perfect for you. Yeah.
Graal VM includes the Graal compiler?
It does, yes. Yeah, because everything all the other things that I talked about are built on top of Graal, the compiler. They need Graal to actually perform well, especially Truffle. If Truffle, you can run Truffle on another JDK or another JVM as well, but it would be freakishly slow. But it needs Graal to produce good code. More questions? Unbelievable, my talk was so good that no questions. Yeah, I think that's the reason. Oh.
How about debugging? Does it have an impact when you are using JVM-TI or JVM-TI?
You mean if JVM-TI has an impact on Graal?
Yes, for the generic development, for example, there's some loop overhauling and something like that.
So don't confuse a compilation with then later runtime. So Graal compiles a method, which is on its own compiler thread. It does stuff, compiles native code, and that native code pretty much looks the same as if it were compiled by C2. It just might be faster or something. But then later at runtime, it's exactly the same. There's no difference. You can use all the tools you want to use. It's just the compilation itself is different. More questions? We're running out of time. We're out of time. Okay, thank you very much.